Additive manufacturing, commonly known as 3D printing, is revolutionizing industries by creating three-dimensional objects layer by layer. Originating in the 1980s, it has evolved with methods like fused deposition modeling and direct metal laser sintering. From prototyping to custom biomedical implants, its applications are vast. The advantages of 3D printing are numerous and quite compelling. They include unparalleled design flexibility, allowing for complex shapes and structures that traditional methods can't achieve. Additionally, it's cost-effective for small batches, making it ideal for prototypes and bespoke items. Not to mention, it's also material efficient, reducing waste significantly. However, like any technology, it faces its own set of challenges. These include material limitations, as not all materials can be used for 3D printing yet. There are also high initial costs involved in setting up 3D printing facilities. And when it comes to large-scale manufacturing, the production speed can be a limiting factor. Despite these challenges, additive manufacturing continues to shape the future of production. Its potential to transform industries and improve product development processes is undeniable, promising a new era of manufacturing efficiency and creativity.